Good morning everyone, welcome to One Concept Per Day portal. This question is on gravitational field and gravitational potential, and part of it is also explains using escape velocity and orbital velocity, and somewhere later part the last question relates to a little bit of astrophysics. Okay, so in total this is not only about gravitational potential, it's about the complete gravitational chapter. A good question, okay, which helps you to understand all the concepts related to gravitation. This question is taken from 2006 November. Okay, so before this we had already solved two questions. You can access these questions from my website or from the playlist that has been uploaded in One Concept Per Day, okay, in YouTube. So these are some of the questions that we have answered. In the first question we have seen like how gravitational potential and gravitational field can be computed using a graph. Okay, and the second question dealt with about what is a gravitational potential and how do you write the gravitational field. What is a gravitational field? Is it a vector, scalar? You learned all this. And then we also looked at what do you mean by weightlessness. So and then we looked at, okay, how do you compare the gravitational potential outside the earth, okay, and as compared to the electric potential, what is the correlation between the gravitation and the electric potential? We've seen this also. In the current question we are still looking at, okay, what has not been covered so far, which is about the next expressions and some part of it related to Kepler's laws. Okay, so this if you learn, I feel if you learn these three concepts or these three problems properly, if you understand this, I think the entire gravitation chapter has been covered. Okay, now let us start with this. So you have a Saturn ring. The diameter of the ring is given over here and the planet is shown over here. Okay, Saturn has several rings, each of which consists of small particles that orbit the planet. Saturn may be considered to be a sphere with its mass m concentrated in the center. Okay, and deduce that for a particle in one of the rings moving in a circular orbit of radius r, the linear speed v of the particle in its orbit is given by the expression gm by r equal to rv square. What is he asking here is that let us consider I have a particle here. I have a particle here of mass m, and with respect to this particle, with respect to the center here, this distance is r. He is asking you to find out or prove that if the velocity v of this ring is given by v over here, this v square this velocity multiplied by this distance should now be equal to g into m. Should be equal to g into m. This is what he has been asked. If you carefully look at this formula, you see that if I push this r downwards, okay, v square equal to gm by r. Now what is this actually? V is nothing but your orbital velocity. So in essence, instead of asking you something like find the or derive the formula for derive the formula for orbital velocity, he has just asked you something like this, right? So in a different way. So you just need to derive the formula for the orbital velocity. How do you start with? You will start with something like this because he is asking you for explain your reasoning. He knows, okay, you will just copy that and put it across. So he is asking you about the explain your reasoning. So what do? You first write that the centripetal force is equal to g mm by r square. For a planet orbiting in a circular path, driving force is equal to centripetal force. This is the principle for circular motion. So you can start from here. Don't start from here. You can say for a particle exhibiting circular motion, we need to have driving force equal to centripetal force. What is driving? So why can't the particle move in a straight line? The reason is because gravity is pulling it. So it is trying to make it move in a circle path, right? So therefore, this should now be equal to gmm divided by r square is equal to centripetal forces mv square by r. Now, before drawing this, you should now write down this is a Saturn of mass m. This is the ring which is moving like this over here of mass m, and this is my r over here. Okay, so you should now draw an arrow over here saying that this is your fg. You should write this as fg here. This explains the whole thing. Now this m, cancelling m on both the sides, you get this. There's a square here, there's an r over here. So what do we have? The next line itself gives you the answer. Cross multiply this, you get this as gm. Therefore, gm is equal to v square by 2r, right? So as required, we have got this. So this for 2 marks. How do you get this 2 marks? First one is for deriving this whole thing, you'll get 1 mark. From here to here, you get 1 mark. And because it's asking for reasoning, so you should draw this particular curve, or maybe you can say for a particle exhibiting circular motion, driving force should be equal to centripetal force. So for this, you'll get 1 more mark. Okay, you write this two, you get the full answer, full mark. Next, one ring, the A ring has an outer diameter of 2.72 into 10 power 8 meter. There is A ring here. This is your A ring. This is your A ring. Okay, your A ring. Then a particle, the mass of Saturn is given. A particle orbits on the outer edge of the ring. Determine the time for the particle to complete one orbit of the Saturn. He is asking you the time taken by the particle to complete one full return. So let us say there is one particle here. Now he is going all the way around, coming back to this point. So what is the time taken? Now we know the velocity or speed of a particle is given by 2 pi r divided by time taken. What is the time taken? Time period of revolution, right? This value of v we can calculate from here. G, m, r, we can use, substitute the value, you get the value of v here. So we will get it, and r is nothing but this divided by 2. This 2.72 in 10 power 8 is diameter. So divided this by 2, divide this by 2 will give me 2 1s are 17, 2 6 are 2 8s are 16, 12, 1.86 into 10 to the power of 8. Why don't we calculate it and see whether I am right or wrong? So 2.72 divided by 2, sorry, see 1.36, I'm sorry, 1.36 into 10 to the power 8 meters. So this is your radius. This is your radius. I'll write capital. So we got all this value. Now what we do is, you need to substitute this value r, and the value of v we get it from here. The answer. So let us do this here. So we know that v square into r is equal to gm, and t 2 pi r divided by v is equal to capital T. We need this value of t here, right? That's what is been asked. What we'll do is, we'll write t is equal to 2 pi by 2 pi r divided by, for v, from this expression I can now write v is equal to square root of gm by r, right here, root of gm by r, which should now be equal to 2 pi into this r goes upwards, r into r power half would be r power 3 by 2 divided by gm whole to the power of half. Now let us substitute all of them. It should be 2 pi into, what's the radius? Radius we just found out, 1.36 into 10 to the power of 8 whole to the power of 3 by 2 divided by square root of g. What is g? 6.67 into 10 to the power of minus 11 multiplied by mass. What is mass? Mass of Saturn is 5.69 10 to the power 26. 5.69 into 10 to the power of 26. Right? We have written all of them. Now let us use our calculator to get this value. So I get 2 into 3.14 multiplied by 1.36 to the power of 3 by 2. 3 by 2 is 1.5. I get this is 9.96. First I'll write down the numerator value. 9.96 into 10 to the power of, here it is 8. 10 power 8 whole to the power of 3 by 2 only. 2 1s are 2 4s are 4 3s are 12. 10 power 12 divided by, now inside the brackets, denominator. Now denominator, what I will do is I'll take 6.67 multiplied by 5.69. I'll get this as equal to 37.95. See here it is 26 minus 11 will be around 26 minus how much it is, around 25, 15. So if it is an even number here in the power, I can easily take. I'll take it as 10 power 14. So therefore, maybe 10 power 16 I will take. I'll take it as 10 power 16 over here. Okay, first I'll write it down. That'll be easy for you to understand this. Square root of 37.95 multiplied by 10 to the power of 15 over here, which I can now write this as equal to 9.96 into 10 to the power of 12 divided by, I'll write this as square root of 3.795 into 10 to the power of, I have taken 0.1 here, so this is 10 power 16 volt. Okay, which should now be, let me take up my calculator once again to find out this value, square root of 3.795. 3.795 square root of this is 1.94 or 1.95. If I take the reciprocal, I'll write it here one by one step. 9.96 into 10 to the power of 12 divided by 1.95 into 10 to the power of 16 square root is 8. 10 power 8 over here, which I can now write. Let me take the ratio of this. 9.96 divided by 1.95. Again, this is 5.1. 5.1 into 10 to the power of 12 minus 8 is 4. 4, what is the unit? This is what is this? Now time. This is second. Okay, so this is the final answer. Okay, now let us go on to the next one. Another particle of mass m is orbiting at a radius r from the center of the Saturn. State a formula in terms of g, m, small m and r for the GPE of the particle. How do you write GPE? So V is given by, okay, GPE, V is equal to G minus Gm divided by R. Okay, and if it is GPE is nothing but m times V. Okay, mass times the potential, which should now be equal to minus Gm small m divided by R. This should be a formula. Because he's just asking you a formula over here, you need not worry, you can just write down this formula, full equation. Either you can do it like this, 2-step, or you can do it by 1 step. Anything is fine. The gravitational potential of this particle decreases. You see, Gp is negative here. As long as the particle is being bound to the planet, definitely it is negative. The more closer it comes, the more negative it is. When you say more negative, that means the Gp is decreasing. Remember this. Okay. Suggest and explain the change, if any, in the linear speed of the particle. What happens to linear speed of the particle? Now, this is the planet. This was the distance r. This was the distance r. Initially, this was your Gp. Okay. Now, what has happened is, he says that the Gp has decreased, which means what? The particle has come closer here. It is somewhere over here. It means what? R is reduced. What will happen to the particle? Particle's velocity will become higher. The linear speed of the particle will become larger. But this is for 2 marks, and the command term is suggest and explain. So what you should do? First, you should write, we know that Gp is equal to minus Gmm by R. Okay? We know that Gpe is equal to minus Gmm by R. Lesser the, not write lesser, you can write if Gpe reduces, this implies R is decreasing. This implies it is coming near to the planet, right? Then what you can write? This implies V0 will increase. Reason, what is reason? You can write down reason also if you want. You can write down, since V0 is equal to square root of Gm by R. When R reduces, V0 increases, right? You can say the linear speed of the particle increases. Then explain the concept of escape speed. So what do you mean by escape speed? Escape speed, what is it? The minimum speed required for a particle to escape from the influence of gravity of a planet. You can mention like this, or you can say, yeah, you can mention until here, or you can say the speed at which the total energy of a particle is 0 in a gravitational field. Why is it 0? Because you know any particle that you take in a gravitational field will always have a negative energy. What is the negative energy? It's been bound to the planet. Okay, so therefore it is minus gm by r, so it cannot escape. So to escape, what you need to do? You need to provide half mv escape square. What is that? Kinetic energy. You need to provide so much amount of kinetic energy such that that kinetic energy is equal to gmm by r. When you do that, what happens? The total energy becomes 0, because total energy is half mv square minus gmm by r, and as a result of it, it becomes 0, and thus the particle is able to escape from the planet. Okay, so that is what I mentioned. Okay, you can write either this definition is more aptful. This is a definition which we use to calculate the value of the escape velocity. If you want, I can write down this like this also. I can write half mv escape square minus gmm by r is equal to 0. When you solve it, you get v escape is equal to a square root of 2 gm by r. In fact, this has not been asked. You need not write this over here. You don't think that, okay, you will get an additional mark by writing this. Okay. Then a planet has a radius r. Okay, we have come back to this question over here. And a planet may be considered to be a sphere with its mass concentrated center. Deduce the escape speed. Okay, so for this, what you need to do? So this particular reason I have mentioned applies over here. Explain your working and state one assumption made in the derivation. Okay, what is the assumption? Assumption is that a particle in a gravitational field of a planet has negative potential energy given by potential energy is equal to minus gmm by r, and hence is bound, or you can say trapped by the planet. Secondly, to escape this trap, the particle needs to be given sufficient amount of energy, that is the kinetic energy, to overcome the negative potential energy. Thus, half mv escape square minus gmm divided by r square should be equal to 0. In other words, v escape is equal to square root of 2 gm by r. Is that what is being asked? No, he is asked 2 gr. So what we do is, now we know that gm is equal to gr square. Substitute this over here, so you get the answer as square root of 2 gr square divided by r. This cancels away, you get 2 gr. V escape equal to root 2 gr. Okay, next let us move on to the next one. This question is a bit bigger one anyway. Calculate the energy speed, escape speed of a planet or spherical planet of radius so much, having an acceleration of free fall at the surface of so much. So this value is g is given to you, radius is given to you. You need to find out escape speed. What's the escape speed? V escape is equal to square root of 2 gr, which should be square root of 2 into 1.6 multiplied by radius is 1.7 into 10 cube, and kilometer, convert it to 10 cube. Always remember, in any physics calculations, you should have every parameter to be converted into SI unit. So when I do this, what is the answer I get? This should now be 2 into 1.6 into 1.7, 5.44. I get the answer as square root of 5.44 into 10 to the power of 6. And when I take out the square root, what do I get? Root of 5.44 will be 2.33. The answer is 2.33 into 10 to the power of 3 meter per second. 2.33 into 10 to the power of 3 meter per second. Let me just find out whether my answer is correct. Yes. So this should be around 2.3 kilometer per second. 2.3 kilometers. Next. The mean kinetic energy in joules of helium-4 atoms at thermodynamic temperature is given by so much. This is your kinetic energy. Determine the surface temperature of the planet such that the helium-4 atoms on the surface of the planet have a escape speed calculated in F. So, if the escape speed of the helium atoms is given like this, what is the temperature of the helium atom? This has been asked. So, what you do is, escape speed is kinetic energy. We will equate that one to here, which should now be equal to half into. So, helium atoms has 4 mass, 4 times 1.67 into 10 to the power of minus 27. This is the total mass of the helium atom. This is mass of one nucleon. Mass of proton and mass of neutron is so much. Multiplied by it has 4 nucleons, 2 protons and 2 neutrons. Multiplied by V escape. What is the V escape over here? V escape we already assumed 2.3 kilometers. 2.3 into 10 cube whole square should now be equal to 2.1 into 10 to the power of minus 23. Okay, so this is for one atom. Okay, so now what we do is, we need to find the temperature T. The temperature T would be equal to 2 ones are 2 twos are 2 into 1.67 into 10 power minus 27 multiplied by 2.3 into 10 cube the whole square divided by 2.1 into 10 to the power of minus 23. When we do this, what is the answer we get? We get the answer as 2 1.67 multiplied by 2.3 multiplied by 2.3 divided by 2.1. I'll just take only the values and then I can do the powers. I get this is 8.41. 8.41 multiplied by 10 to the power of, I have minus 27 here, then 3 square will be plus 6, minus 23 comes upwards, becomes plus 26, plus 26. So when I simplify this, I get the answer as 8.41 into 10 to the power of 6, I am sorry, this is 23 here, 23 plus 6 is 29, 29 minus 27 is 2, it should be 841 for the unit. We go back here, it should be in Kelvin, right? So thermodynamic temperature T is given in Kelvin. It should not be written in Celsius, it should be 841 Kelvin. It's your final answer. Now suggest one answer why at temperatures below that calculated in G, below 841 K, helium will escape from the planet. So you should have at least this much. Okay, why should it escape from the planet when the temperatures are below this? One of the reasons you can say is that when the temperature is below this, see, when you have a temperature like this, now let us look at the fission and fusion reactions happening. When the temperature is so much, what can happen is the helium atoms can now start, helium nuclei can now start fusing with each other to give rise to higher nuclei. But if suppose if the helium nuclei temperature is much lesser, fusion will not happen. When fusion does not happen, then what happens? There is a lot of collisions between the atoms, and as a result of it, they can escape. It's one of the reasons you can say. So with this, I think we have come to an end to the gravitational potential and field questions. I hope you would have understood more about how to solve these questions. So if you have liked these problems, do like, share and subscribe to my channel for more updates. You'll get every day as much as possible. I'm trying to do it. Sometimes, school work will be so much, submissions are coming on, so it may not be possible for me to put across one problem every day, but as much as possible I'm trying to do it from my end. So Sunday, somehow I got some time, so I was able to. I think tomorrow you may not have any problems. I am trying to make videos on the 2024 November paper, and tomorrow onwards I think it will be uploaded. Okay, thank you.